Okay, up next, our speaker is from Fort Valley State University. This is Dr. George Mbata. He is the professor of entomology and crop protection. He will be giving the Fort Valley State University whitefly research update.
Okay. Yeah, thank you. Good afternoon, everybody. I'm going to speak on a project we've been doing, I think, for about 3 years now. We are carrying out several studies to investigate mitigation of whiteflies on vegetables. Okay, yeah. We are working on 3 crops: snap beans, tomatoes, and vegetables. The first thing we did was to establish that whiteflies are problems on these crops. So we did a literature review, which we published in 2021. Our first study took us into biological control of whitefly using entomopathogens. And we started with entomopathogenic nematodes. We used the 9 nematode strands, I think 4 of them were stereonamidids, and 5 were heterorabidids. Of all this, we screened them in the laboratory and found out that H. floridensis was the most virulent strain to whitefly nymphs. Then we also compared this with on snap beans and also on tomatoes. We found that they were more effective. There was more mortality of whiteflies on snap beans. This information was again published in Nematology, Journal of Nematology. The next thing we did was to look at the susceptibility of 24 snap beans cultivars to whiteflies. We run this on the experimental farm of Fort Valley State University. Of the 24 crop varieties, we found that 5 of them were the least susceptible, and they included Royal Burgundy, Jade, Goldenrod, and long-term wren. Highly yielding variety was a PV 857 momentum affirmed anthema. Indeed, the high yield was not in any way related to infestation by the whitefly. So a different experiment was planned to compare yield as affected by whitefly infestation. And we published this paper in Crop Protection. Then we also looked at the attractiveness of different snap bean varieties to beneficial insects, that's pollinators as well as natural enemies. So we want to determine if there are certain cultivars that encourage the recruitment of pollinators and others that can also sustain natural enemies, some of which could go after the whitefly strains. So this study showed us that the number of whitefly eggs was least on cultivar Jade, and the number of whitefly nymphs was least on cultivars Goldmine, Goldenrod, long-term wren, and Royal Burgundy. Cultivars green cockroach and PV857 harbored few adult potato leafhoppers and tarnished plant bugs. Pollinators identified included bees, honeybees in particular, and bumblebees and other bees. The moths we found included the Alentus webworm moth, and the wasps were yellow jack wasp and wasps within the other Sphaecidae. The natural enemies identified included predators as well as the parasitoids. The predators were Delphastus and Delphastus, leadbed beetle, and while the parasitoids were Acacia and Erotomecerus genera. We also found the minute parrot bug, Orius species. Population of adult whitefly was found in week 1. That's week 1 of our observation. That's about the 3rd week of planting. And the Mexican bean population, beetle, also was found the 1st week of observation, which falls on the 3rd week of planting. Then week 3 of observation, we found the predominant insects were the cucumber beetle, kuzu bug, and the potato leafhopper. Then on the 4th week of observation, we had thrips, and week 4, we had the tarnished bugs. Week 5 and 6, the bees were predominant, and these when the flowers of the snap beans matured. So apparently, the attractiveness of these insects is ascribed to plant odors that were emitted. We also found that temperature and relative humidity correlated with populations of whitefly, the Mexican bean beetle, bees, and the predatory ladybird beetles. We've already submitted this study for publication with Insect, the journal Insects. We've attended several conferences since the initiation of this project. That's the beginning 2020. The conferences we attended included those organized by ESA, the Southeastern Branch ESA, then Southeastern Regional Fruit and Vegetables Conference. Yeah. So activities planned for this year would include a evaluation of there's a further evaluation of the efficacy of entomopathogens, entomopathogenic nematodes and fungi against whitefly. Apparently, we've carried out the first laboratory study that we are going to repeat that experiment. And another thing we are doing now is since we know that these pathogens do not survive long exposure to environmental conditions, particularly low humidity or UV lights. We are planning to dispense them along with several media that could protect them against the UV light or low humidity. We are going to conduct another field experiment with yield, that's for snap bee yield, to determine if the impact whiteflies have on the reduction of snap bee yield. And this would really maintaining a control plot that will require neither use of pesticides or that will be far away from from other studies. We are going to compare the yields for various cultivars, and we have to use pesticides to protect the control. So we are moving the plot far away from the other trials that will not be protected to prevent pesticide drift. Then the EPN studies, we intend to transition from laboratory to greenhouse in this 2023. These are members of the laboratory team. Some of them are working on different projects, but the key person on this project is Dr. Yimping Lee. She's behind. If you have any questions, she probably will help in addressing them.
We have any questions for Dr. Mbata? Okay. All right, if not, thank you for your presentation, Dr. Mbata.
Yeah.
So we are a little...
Yeah.
Are y'all using a trap crop for these whiteflies?
No, not yet. Mm-hmm.